Okay, so we are starting chapter 4, 3 chapters down, and you are starting and ending your study of probability in this statistics course. It has a space for it, but we're not going to labor over the very difficult probability questions. Why are we talking about probability at all? So when you finish chapter 3, there was heavy emphasis in the last 2 sections about what's considered a significant event, and we used a standard deviation to decide whether something was a significant value. Well, probability can also help answer that question as well. If there is a very low chance that something occurs, then you would say that that event is significant. And so that's why we are bringing probability into this course, and try to bear with it. It's very mathy. There are some basics of probability for you to know the language. An event is any collection of results or outcomes. What you're going to see a lot in the next couple of chapters is the event of having a child. It's either going to be a boy or it's going to be a girl. And so that would be the event is having a child, and then the 2 outcomes would be boy or girl. A simple event is an outcome that can't be broken down any further. So that was a simple event, having a child. Sample space consists of all the possible events that could occur. So if I said, that the event was having a child, then the sample space would be 2, boy, girl. If I said, well, what would be the sample space of having 2 children? It gets a little more complicated, and that's what we're going to be looking at today in today's video that deals with probability, is drawing how do I calculate the sample space? There's notation that is related to probabilities that you'll see in this chapter, but not really that much more outside of this chapter in this course. P, capital P is probability. P parentheses A would be the probability that A would happen. They say A, B, and C because you could put P of B, what's the probability that B is going to happen. And to calculate probability, you need to figure out what the sample space is, because you take the probability of event A occurring and you divide it by all possible things that could happen. So you're going to be making some fractions, and we can change fractions into decimals, and we can talk about probability using percentages as well. Don't make the mistake of putting a smaller value on top. It is a fraction, and it's the probability of something happening divided by total probabilities or total possible outcomes. So you're always going to have a smaller number on top of the bottom. And then when you divide, you take the top number divided by the bottom. We're talking basics here, and we're starting slow, and we're not going to go too heavy into the probability. 3 sections. Here's the first one. So probability is a fraction or decimal that has to be between 0 and 1. If there's a 5 out of 5 chance that something's going to happen, that's 100%. Probability is 1. Probability of the impossible is 0. And the notation here you're going to see in the first 2 sections is the probability that an event does not occur is when they put a little bar on top of the letter. And that'll be more so in the second video. You'll also see it in the next section. So let's take a look at this example. In a Pew Research Center survey, randomly selected adults were asked if they have seen or been in the presence of ghosts. 366 of them said yes. 1,637 said no. Based on these results, find the probability that a randomly selected adult says that they have seen or been in the presence of a ghost. So probability is probability of the event occurring divided by the total. And in this case, we don't have a total because all we have are the number of people that said they have and the number of people that said they haven't. So the first thing you want to do is take, you see me sidebar over here. I'm adding 366 and 1637. and I am getting a total. Please do that right now. And then trying to find the probability that they have seen a ghost. And so I'm going to take the amount that said yes and divide it by the total. And I'm hoping that you are doing this while I am doing it. And so with your fancy graphing calculators, you don't have to decide which number you start with and which one you divide by. It makes it a fraction for you. So this was the total here of the number of respondents, and I'm looking for the probability that if I randomly selected a respondent, that person has been or has seen been in the presence of or seen a ghost. And so it converts it to a decimal between 0 and 1. So if I wanted to change this into a percentage, I would bump this back twice. And then I can say that 0.18 is equal to 18%, working with percentages in that first chapter, right? But that I could say there's an 18% chance that if I randomly selected an adult they had seen or been in the presence of, or I can say that the probability is 0.18. So it's difficult to provide a universal rule for how to report it. I'll take either. They're saying that you should round to 3 significant digits. Again, this book does a lot of talking about rounding, but typically your homework, it will say it. I will put it in an exam. And so I'm not going to mark you down for poor rounding, but your textbook would mark it wrong. And it's just kind of a hassle to have to go back and fix it. Or on a quiz, you don't want to miss little points just for rounding. So it's not that it's not important to talk about rounding, but it's not a decision that necessarily you have to make. They'll tell you how to round. So they say if you get like a 1 out of 3, you should just leave it as a fraction. 1 divided by 3 is 0.33 repeating. And so you don't want to just say it's 0.3 because that's like a 30% chance. And that's not as accurate as we can be. It's more of like a 33.3% chance. And already you're bored, right? I'm just kidding. No, but again, probability can get very, very tricky. And we're doing the basics today. Again, so basically it's a fraction, the probability of the event occurring divided by the total possibilities. And in the case of a survey, your total would be the total number of people that were in the survey that were asked. So, some of this is going to get tricky with the fractions. And so here's a question that I want you to answer. Again, I hope that you've got your calculator with you. What is the decimal equivalent for a probability that is 1 out of 3,256? And use your calculator to calculate that. So I'll give you a moment. I'll switch over so that you can see mine. And so if I were to take this fraction and enter it, 1, I hit the division button. So to create fractions, you would just divide, right? 3, 2, 5, 6. What you end up seeing in your calculator, a lot of people tell me this is 3.07. But remember, probability has to be between 0 and 1. And so understanding what this means off to the side is very important here. So 3.07125, sorry for the messing handwriting, e to the -4 means times 10 to the -4th power. And so you have to bump this decimal 1, 2, 3, 4 times to be able to give me the approximation. So 1 bump just gets me in front of the 3, 2, 3, 4. That's going to give me 3 zeros and then the 3. So that's less than a 1% chance, which makes sense if you weren't busy converting a decimal, fraction to a decimal. 1 out of 3,256, that's not even 1%. That's not even half of a percent. It's 0.0003, which would be bump it twice, 0.03 percent. You see me stumble a little bit there. So this is the first video about the basics of probability. It's the beginning of chapter 4, but honestly, you get it heavy in chapter 4. Don't feel like the rest of the semester is going to be like this. So 0.25 is equivalent to 25%, but please don't use percentages in your answer. It's better to talk about probability as 0.25. If you interchange them in your restatement of your answer and you say there's a 25% chance, that's fine. But there are good reasons to not convert. There are good reasons to not change a decimal and use the percentage symbol. You kind of saw me, like I said, stumble a little bit there. I was like 0.0003%. You know, it's safer in this space for the purposes of what we are studying this for, is to not change it to a percentage, and let's just say probability. There's a 0.25 probability of something occurring. Professional journals almost universally express probabilities as decimals, not as percentages. Later in the book, we're going to use probability generated from statistical software. So again, if you use it interchangeably because it makes more sense to you to answer these probability questions, I won't mark you down, but practice saying that the probability is 0.25. And also, you know, those less high-powered calculators actually have a percentage button. This one doesn't, so just don't use the percent. Okay, that is the short video as an introduction to probability. We will pick up on the next one, talking about sample spaces in the next video.